Electrical wiring in residential buildings is a critical aspect of modern living, providing power for lighting, appliances, and various other conveniences. Understanding the fundamentals of electrical wiring ensures safety and proper functioning of electrical systems. Firstly, let's discuss the types of wiring commonly used in residential buildings. Non-metallic sheath cable, often referred to as NM cable or Romex, is a prevalent choice for interior wiring. It consists of two or more insulated conductors enclosed in a non-metallic sheath, typically made of plastic. NM cable is suitable for dry locations and is available in various sizes such as 40-2, 12-2, and 10-3, with the numbers indicating the gauge of the conductors and the number of current carrying conductors plus a ground. Secondly, armored cable, known as AC cable or BX cable, features conductors wrapped in a flexible metal sheath. AC cable offers enhanced protection against physical damage and is often used in situations where the wiring is exposed or subject to potential impacts. However, it is essential to ensure proper grounding when using AC cable to mitigate the risk of electrical shock. Thirdly, metallic conduit is another wiring method that involves running conductors through rigid or flexible metal tubing. Conduit provides excellent protection against physical damage and moisture, making it suitable for both indoor and outdoor applications. Common types of conduit include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. Choosing the appropriate type of conduit depends on the specific application and environmental conditions. Proper grounding is paramount in electrical wiring to ensure safety and prevent electrical shock hazards. Grounding provides a low resistance path for fault current to flow back to the source, tripping the circuit breaker or fuse into energizing the circuit. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, connected to the electrical panel and all metallic enclosures and equipment. The National Electrical Code, or NEC, provides comprehensive guidelines for grounding requirements in residential buildings. Circuit breakers and fuses are essential components of electrical systems, providing overcurrent protection to prevent damage to wiring and equipment and to minimize the risk of electrical fires. Circuit breakers are resettable devices that trip when the current exceeds a predetermined level, while fuses are one-time devices that melt and break the circuit when subjected to excessive current. The size of the circuit breaker or fuse must be matched to the ampacity of the wiring and the load it serves. NEC Table 310.15b16 provides guidance on ampacity ratings for various conductor sizes and insulation types. Wiring configurations in residential buildings typically involve both 120 volts and 240 volt circuits. 120 volt circuits are used for lighting, small appliances, and general purpose outlets, while 240 volt circuits are used for large appliances such as electric ranges, dryers, and air conditioners. The 120 volt circuits are typically supplied by a single pole circuit breaker, while the 240 volt circuits are supplied by a double pole circuit breaker that connects to two hot wires. When working with electrical wiring, it is crucial to follow safety precautions to prevent electrical shock and other hazards. Always to energize the circuit before working on any wiring by turning off the circuit breaker or removing the fuse. Use insulated tools to avoid contact with live wires. Wear appropriate personal protective equipment, such as safety glasses and rubber gloves. Never work on electrical wiring in wet or damp conditions. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Electrical panels, also known as breaker boxes or load centers, serve as the central distribution point for electricity in a residential building. The electrical panel receives power from the utility company and distributes it to various circuits throughout the building. The panel contains circuit breakers or fuses that protect each circuit from overcurrent. The size of the electrical panel is determined by the total electrical load of the building and the number of circuits required. The NEC provides guidelines for sizing electrical panels based on the calculated load. Common wiring configurations in residential buildings include series circuits, parallel circuits, and series parallel circuits. In a series circuit, All components are connected in a single path, so the current is the same through all components. If one component fails, the entire circuit is interrupted. In a parallel circuit, components are connected in multiple paths, so the voltage is the same across all components. If one component fails, the other components continue to function. Series parallel circuits combine elements of both series and parallel circuits. Electrical boxes are used to enclose and protect electrical connections, such as outlets, switches, and wire splices. Electrical boxes are typically made of metal or plastic and come in various shapes and sizes. The NEC specifies the types of electrical boxes that are suitable for different applications. Wire connectors, such as wire nuts and terminal blocks, are used to join wires together securely and safely. Wire connectors must be properly sized for the gauge of the wires being connected and must be listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. Ground fault circuit interrupters, or GFCIs, are special types of outlets and circuit breakers that protect against electrical shock by monitoring the current balance between the hot and neutral conductors. If a ground fault is detected, the GFCI trips the circuit and interrupts the flow of electricity. GFCIs are required in wet locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or RFCIs, are circuit breakers that protect against electrical fires by detecting arc faults, which are dangerous electrical discharges that can occur when wires are damaged or connections are loose. RFCIs are required in many areas of the home, such as bedrooms and living rooms. When installing or repairing electrical wiring, it is essential to comply with the National Electrical Code, or NEC, which is a set of standards and regulations that govern the safe installation and maintenance of electrical systems. The NEC is updated every 3 years, so it is important to use the latest edition. Many local jurisdictions also have their own electrical codes, which may be more stringent than the NEC. Understanding the different types of electrical wiring, safety practices, and common wiring configurations is essential for anyone working with electrical systems in residential buildings. By following the NEC and adhering to safety precautions, you can ensure the safe and reliable operation of electrical systems. Now let's delve a bit deeper into specific aspects of residential electrical wiring. Consider the importance of wire gauge. The gauge of a wire refers to its diameter, and it's inversely proportional to the wire's ampacity. This means a smaller gauge number indicates a thicker wire with a higher ampacity. Common wire gauges used in residential wiring are 14 gauge, 12 gauge, and 10 gauge. 14 gauge wire is typically used for 15 amp circuits, such as lighting and general purpose outlets. 12 gauge wire is used for 20 amp circuits, often for kitchen and bathroom outlets. 10 gauge wire is used for 30 amp circuits, like this for electric dryers or water heaters. Choosing the correct wire gauge is crucial to prevent overheating and potential fire hazards. Next, let's discuss electrical boxes in more detail. The NEC specifies the minimum size of electrical boxes based on the number and size of conductors, devices, and fittings within the box. Overfilling an electrical box can lead to overheating and difficulty in making proper connections. Electrical boxes come in various materials, including metal and plastic. Metal boxes provide better protection against physical damage, while plastic boxes are non-conductive and easier to work with. Proper grounding of metal boxes is essential to ensure safety. Furthermore, consider different types of switches and receptacles. Single-pole switches control a light or outlet from one location. Three-way switches control a light or outlet from 2 locations. Four-way switches are used in conjunction with three-way switches to control a light or outlet from 3 or more locations. Receptacles, also known as outlets, provide a point of connection for electrical devices. Standard receptacles are rated for 15 amps or 20 amps. Ground fault circuit interrupter, or GFCI, receptacles are required in wet locations to protect against electrical shock. When working with electrical wiring, it's crucial to understand how to properly splice wires. Wire nuts are the most common type of wire connector used in residential wiring. To properly splice wires using wire nuts, Strip the insulation from the ends of the wires, twist the wires together, and then screw the wire nut onto the twisted wires. Ensure the wire nut is securely tightened to prevent loose connections. Terminal blocks provide a more secure and organized way to splice wires, especially in electrical panels. Terminal blocks consist of a series of screw terminals that allow you to connect wires without twisting them together. Always follow the manufacturer's instructions when using terminal blocks. In addition to the NEC, many local jurisdictions have their own electrical codes that you must comply with. These codes may be more stringent than the NEC and may address specific local conditions. Always check with your local building department to determine the applicable electrical codes for your area. When troubleshooting electrical problems, it's essential to use a multimeter to test for voltage continuity and resistance. A multimeter is a versatile tool that can help you identify the cause of many electrical problems. Before using a multimeter, make sure you understand how to use it safely and properly. Always to energize the circuit before testing for continuity or resistance. Electrical wiring is a complex and potentially dangerous field. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. A qualified electrician has the knowledge, skills, and experience to safely and effectively install, repair, and maintain electrical systems. Remember, safety should always be your top priority when working with electricity. Now consider surge protection. Surge protectors are devices designed to protect electronic equipment from voltage spikes. These spikes can damage or destroy sensitive components. A whole house surge protector is installed at the electrical panel and protects all circuits in the home. Individual surge protectors can be used for specific electronic devices such as computers and televisions. It is important to choose surge protectors that are rated for the appropriate voltage and current. Arc fault circuit interrupters, or size, are a crucial safety feature in modern residential wiring. A size detects arc faults, which are unintended electrical discharges that can cause fires. They are designed to trip the circuit when an arc fault is detected, preventing a fire from starting. The NEC requires a size in many areas of the home, including bedrooms, living rooms, and dining rooms. Grounding electrode conductors, or GECs, are used to connect the grounding electrode to the electrical panel. The grounding electrode is typically a ground rod, a metal water pipe, or a concrete-encased electrode. The GEC must be sized according to the size of the service entrance conductors. Proper grounding is essential for safety and to prevent electrical shock. Bonding is the process of connecting all metallic parts of an electrical system together to create a low-impedance path for fault current. This includes metal conduits, metal enclosures, and metal water pipes. Bonding helps to ensure that all metallic parts are at the same electrical potential, reducing the risk of electrical shock. The NEC provides detailed requirements for bonding electrical systems. Understanding voltage drop is important when designing and installing electrical circuits. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause lights to dim, motors to run slowly, and electronic equipment to malfunction. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, use larger conductors or shorten the length of the circuit. Electrical permits are required for many types of electrical work, including new installations, alterations, and repairs. A permit ensures that the work is inspected by a qualified electrical inspector and that it complies with the NEC and local electrical codes. Contact your local building department to determine the permit requirements for your area. Electrical inspections are conducted by qualified electrical inspectors to ensure that electrical work complies with the NEC and local electrical codes. The inspector will examine the wiring, grounding, bonding, and other aspects of the electrical system to ensure that it is safe and properly installed. Passing the electrical inspection is required before the electrical system can be energized. Finally, be aware of future considerations. As technology evolves, residential electrical systems will continue to become more sophisticated. Smart homes, electric vehicles, and renewable energy sources will require new wiring methods and technologies. Staying up to date with the latest electrical codes and technologies is essential for anyone working in the electrical field.